On the planet Mars, the gravitational acceleration is 3.7 meters squared. Suppose a rock is thrown upward at a speed of 20 meters per second at an angle of 70 degrees above the horizontal. Find the time of the rock's flight and the maximum height it reaches. So first we're going to start by drawing the problem out and visually seeing what this would all look like. So I'm starting by drawing the base of the planet Mars, and then I'm drawing the arrow, which is the rock that it's being thrown at. I'm drawing the dashed line that it's going to go into the parabolic path, which is the path it's going on. And yeah, the 70 degrees is the angle that the rock is being thrown at. So the 20 meters per second is our initial velocity, and that's the speed that the rock is being thrown up at. So the rock is being shown as the arrow that's going to be thrown up into the air, and then it comes back to the surface of the planet. We want to find out the time and the height. So the key to projectile problems is to do the horizontal and the vertical projectile independently. So you want to find the horizontal aspect of the problem, and then you want to find the vertical. To do that, we have to break this vector up, which is the 20 meters per second speed rate. So the horizontal is the v0x, and the vertical, which is the up motion, is the v0y. So we can find these. The v0x is the 20 meters per second, and you're going to find the cosine of that, which is cosine of the angle that is 70 degrees. So you punch those in the calculator, and what you want to do is you want to make sure that your calculator is in degree mode. So for the horizontal, you're going to get 6.84 meters per second, and v0y, you're going to get 18.79 meters per second. So now let's deal with just the vertical motion here. Is going to determine how high it goes and how much time it spends in the air. So I know my initial velocity is the vertical component, which is the 18.79 meters per second. So note that I stated that the vertical velocity is the 18.79 meters per second. That is the vertical velocity. And it's a positive number because Now, we know that the vertical velocity is positive because it is going up. The acceleration is going to be negative. So be careful here because the acceleration is not going to be negative 9.8. And that's because we have a listed acceleration that is 3.7 meters per second squared. And it's negative because, as I said before, it is going down. So now, the vertical velocity is going to be from the bottom to the start of the peak. And that is indicated by the purple arrow, which is going to the right. So we know that the vertical velocity there is going to be 0. So now that we have all the information that we can use for an equation to solve for this, we have the acceleration, which is the negative 3.7 meters per second, the initial velocity, and the velocity that we found for the horizontal. So we're going to use the equation v equals v0 plus a times t. So the only thing that we don't have is time. So what we can do is we can rearrange that. So we can do t equals v minus v0 over a. All the information that we have solved for and found, we can plug that in. So now we can figure out that the meters are going to cancel out, and we have seconds squared, so second squared cancels out, and then we have 1 second variable left. And in addition to that, the negatives are going to cancel out, so we'll be left with a positive number. So now that we have the 5.8 seconds, that is from the bottom to the peak. So in order to find the total time, we're going to just double that. And that, for simple math, that is just going to be 10.16 seconds. So now that we've solved for the time, we have to solve for the height. So we're going to do that with this equation, y equals y0 plus vot plus 1/2 times a t squared. So we're just going to plug in with the numbers that we've used, 0 plus 18.79 meters per second times 5.08, which is the seconds that we found, times the acceleration, negative 3.7 meters per second, and times the time again, squared. So now if you were to do the math right, you would get 95.45 meters minus 47.74 meters, which equals to 47.71 meters. So if the math were to be done correctly, the 47.74 meters is exactly half of the 95.45 meters. So just to round for sig figs, significant figures, we're going to round this up to 48 meters. And that is exactly how you do this problem. Thank you for watching.